Forces are a very important element of any particle system on pretty much any platform, and the same holds true for particle flow. Forces, as in the real world, act upon our particles and alter our particles' speed or direction of travel, and perhaps even slow our particles down. In the real world, we have physical forces such as gravity, which is a very weak force which can act over very massive distances. We have magnetism, which is a much stronger force, but which only has a very limited range of effect in comparison to gravity. We have electrostatic forces between charged particles, such as dust. We have the flow of gases past objects that can have a varying effect on them based on their aerodynamic nature, and surface friction levels, and so on. So, forces can change the motion of our particles in a number of ways, and to take this into account, we can use the force operator in conjunction with any of the 7 core force space warps in 3ds Max. Of these 7 forces, 6 of them will have a positive effect on our particles and will generally impart some form of energy to them. However, the drag force does the opposite and will act to drain any energy your particles have in them. Anyway, let's have a look at each of the forces in action and what each can be best used for. And at the end of this section, let's have a closer look at the force operator itself and some of its finer points. We'll start with the most commonly used and most useful forces first, and then move on to the more esoteric forces later. Before I continue, let me explain about something which we're actually using inside this scene here. You can see that we're actually using a plugin called Force Viewer, and this was actually written by John Burnett, who actually works at Blizzard at the moment. Now, unfortunately, this tool, although it was actually given away as a freebie at the time, has actually been pulled, so I can't actually include it with the DVD. But I thought it was actually worth using it with the DVD to give you an insight into how each force actually works. Now, what the Force Viewer does is it allows you to take a space warp, a force space warp, and display the vectors of that space warp in action. It's a very, very cool tool. If you've ever used any of these space warps in Max, the force space warps, it can be very hard to work out sometimes exactly what they're doing. So you can actually see when you actually use this particular utility how the vectors of the actual force are being applied within its area of effect. Now, this particular helper, as you can see, has dimensions for the size. You can see we've got an X size, Y size, and a Z size, and I've set all those to be the same. So basically we've got a cube here. And then you've got an option for the resolution of the number of vectors that it'll actually show you. So if I put this down to a lower value, you can see now we only have, if I actually just turn off this particle flow for a second, you can see now that we only have 10 vectors by 10 vectors. And as you can see, the Z resolution is set to 1. If I set that to 10, you'll actually see that they fill the volume now. Now, in this case, they're actually all pointing at this gravity object here. You can see all the vectors are pointing to it, and that gives you an idea of how the force is actually working. So I'll just put that back to the way that I had it set up previously. I tend to use this kind of setup most of the time with this particular thing, because using a planar demonstration of force often gives you, a slice through the force field and gives you a kind of clearer idea of how that force field is actually built up. If you use the 3-dimensionality of it by using, more than one value in Z, as you can see, you get a 3-dimensional view, but you end up with so many vectors you can't actually see what's going on. So we'll just put that back down to 1. And now we'll actually use this tool to have a look at the actual gravity space warp. Now, we all know how gravity is a force that attracts objects with any mass together over great distances. And we also know that objects with a larger mass exert more gravitational force on objects under their effect. In the real world, we generally see gravity affecting objects in an apparently planar manner, i.e. all objects are pulled downwards towards the ground. Whilst this is how it actually appears to us, we know that in fact the force is an omnidirectional force, and only appears to be planar as we are relatively tiny objects on a very large gravity source, which is of course the Earth. For the gravity space warp, we have these main parameters. Let me just freeze this utility, because we can still just about see the actual lines while it's frozen, and it actually allows me to select the space warp more easily. You can see that the first parameter that we have is the strength parameter here. And the strength parameter is of course the amount of gravity that should be applied to all our particles. It will have a linear effect when the following decay parameter is set to 0.